The last type of limit that we're going to consider for L'Hopital's rule is indeterminate powers. These are things of the form 0 to the 0, infinity to the 0, or 1 to the infinity. Because in these cases, the base and the exponent are pushing the limit towards opposite things. So 0 to any power is 0, but anything to the 0 power is 1. So is the limit 0 or 1 or something in between? Here, if the base is getting infinite and the exponent's approaching 0, well, a bigger base to any power should go to infinity, but anything to the 0 power is 1. So who wins out, 1 or infinity or somewhere in between? And then 1 to any power is 1, but if that's slightly bigger than 1 and you take higher powers on it, that goes off to infinity. So with all of these indeterminate forms, we're going to take a log on both sides, and that'll change it into 0 over 0, infinity over infinity, or 0 times infinity. Then we'll find the limit of that easier expression using L'Hopital, and then exponentiate when we get done. Now just a note, 0 to the infinity power, that's a determinate form. If the base is approaching 0 and the exponents get bigger and bigger, then the limit's going to be 0. And infinity to the 1, if the base is getting bigger and bigger and the exponent's approaching 0, then the exponential expression will approach infinity. So let's look at an example here. Limit as x goes to infinity, 1 plus 1 over x to the x. So this 1 over x is going to approach 0. So the base here looks like 1 plus 0 or 1. And then our exponent x there goes to infinity, so that's 1 to the infinity, so that's an indeterminate power. So let's take and set y equal to the 1 plus 1 over x to the x power. And then we will take logs of both sides. So ln of y will be ln of 1 plus 1 over x to the x power, and that x is an inside exponent, so that'll pull down in front. So this is x times the natural log of 1 plus 1 over x. And now we want to take the limit of this expression. So the limit as x goes to infinity of the natural log of that expression y is the limit as x goes to infinity of x times the natural log of 1 plus 1 over x. And x is going to infinity, so this is infinity times this piece is going to 1. So log of 1 is 0, so infinity times 0. So we want to bring something down to the denominator. The x is going to be easier to bring down. So this will be limit as x goes to infinity. Up on top we've got natural log 1 plus 1 over x. And then in the denominator we've got x to the negative 1. And now the 1 over x in the denominator goes to 0. Log of 1 plus 0 goes to 0. This is now form 0 over 0. So we can use L'Hopital's rule. So we're going to differentiate top and bottom separately. So on the top, this is the log of a function. So let's see here, limit x goes to 0. And then here's our main dividing bar. On the top, we've got log of a function, g of x, so that derivative is going to be g prime over g. So function goes on the bottom, 1 plus 1 over x. And then its derivative goes on top. Derivative of 1 is 0. 1 over x is the same as x to the negative 1, so that derivative is negative x to the negative 2. And then derivative of x to the negative 1 there is negative x to the negative 2. And now we want to simplify as much as possible. So we want to take this and invert and multiply here. So this will equal limit x goes to infinity. We've got negative x to the negative 2 over 1 plus 1 over x, and then invert and multiply this guy. So 1 will be on top and negative x to the negative 2 in the denominator, and then the negative x to the negative 2's cancel. So we are now just doing limit x goes to infinity of 1 over 1 plus x. I'm sorry, 1 over 1 plus 1 over x. And now your x is going to infinity, so the 1 over x approaches 0. That's 1 over 1 plus 0, which is 1. So what did we show? Well, we showed that ln of y approaches 1. We want to know what's happening to y. So we're going to exponentiate on both sides. So e to the ln y will approach e to the 1, which is e. So that exponentiating there is undoing this logarithm on both sides here. So this limit is e. So it ended up between the 1 and infinity. 1 to any power is 1. Infinite power on a number that's slightly bigger than 1 goes to infinity. So ended up in between. And if you remember, this is the same limit that we did using the derivative of the log function earlier in the chapter.